I'm making this video because most railroad anvil videos don't deal with the hardy hole. So this one will focus on my experiences in making hardy holes and rail anvils. I don't talk about Purchell holes in this video, but I generally make them 3/8 of an inch in diameter. But if you understand the rest of the information herein, you won't have any trouble producing the Purchell hole. Go to our Rail Anvil webpage for general information on rail anvils. The bigger the rail, the higher the degree of alloying, the harder it is to drill. You can see from this chart how the standards for just the carbon content increase as the size of the rail increases. Other alloys, such as manganese and silicon, are also added, and most of those additions will increase drilling difficulty too. Remember that railroad rail is classified by weight in pounds per yard of length. So when I say 112-pound rail, I mean 1 yard of the material weighs 112 pounds. It's not the weight of the piece that I am working on. Here you see a range of anvils. Their size, weight classification, and carbon content range. By the way, I have been using high-speed steel drill bits for doing the hardy hole and Purchell hole drilling so far, but I always use a 1.5 inch diameter carbide insert face mill for milling the faces, and I run that mill at about 350 RPMs. I always center the hardy hole from side to side. Look at some similar size anvils that you can find to determine the distance from the heel that others have used to locate the hardy hole. I recommend leaving at least 2 inches of heel end anvil face intact so you can use the heel end of the face for forging. Here's a commercially manufactured hardy hole. It comes in different sizes. The cool thing about this is that if you don't want to go to all the trouble of working on making square hardy holes, you can just drill a round hole, buy a piece of this, cut off the length you need, and just tack weld it in place in the hole. And there you have it. This comes from Green Bay Manufacturing Company. What's going on here? I made the darn thing 3/4 of an inch square. I measured everything very carefully, and I milled it, and I have a digital readout on the mill, and the darn 3/4 inch hardy tooling still doesn't fit. Why could that be? Well, I used to make the hardy holes the exact nominal size that was my goal. That is, if I wanted a 3/4 inch square hardy hole, I'd make it 3/4 inch. Exactly 0.750 plus 5 thousandths minus nothing both ways. But most of my 3/4 inch hardy tooling is actually a tiny bit bigger and not necessarily square. So now I make the hardy holes 1/64 to 1/32 larger than that nominal size. You can see that I first lay out the center for the main hole, then I locate the 4 corner holes so the edges of those holes exactly touch the edges of the hardy hole to be. I use 3/16 drill bits for the corner holes. Smaller bits would leave less material in the corners, but they can't take as much abuse as the 3/16 drill bits can. Here you can see why I drill out these corner holes. This part of the process removes about 65% of the corner material that I'd have to file out otherwise. I've been cutting the hardy relief area before I drilled and milled for the hardy holes. This, of course, is one style, a London pattern style. And this one, this hardy hole relief, is a style I got from an idea by Bernard Hare some years ago in a book that he wrote about Africans making anvils out of locally available stuff. But the flame cutting process apparently hardened the steel about 1/8 of an inch deep, making the drilling of the last part of the hole slow going. On the good side, it gave me an opportunity to hone my hand drill bit sharpening skills, but that's not a lot of help when you're trying to get the job done. I even tried to flame anneal one of these hardy relief areas, but that didn't help much. So for future rail anvils that I make, I will do the drilling before I flame cut the heel relief. This process change will make drilling easier, but I'll still have to deal with filing the short hardened part of the hole. There is another option, one that I have not tried. After drilling out the hardy hole from the face, but before filing, turn the anvil on its side and drill out the relief area. This should keep the whole area from hardening at all. Now that I think about it, one could drill and mill from the side first, making the drill's exit from the face more visible. If I do use this process, I'd still have to flame cut the rest of the heel relief area. If I stay away from that newly cut hole, filing should be a lot easier. There, I just finished drilling the last of the 3/16 holes that I need, 1.5 inches deep. This is a large size rail. I probably had to resharpen drill bits 8 or 10 times to get this far. For this larger anvil, I have already drilled 1.5 inches deep, as you can see here. And you can also see in this area here that the bit hasn't broken through the ball yet in any one of those areas. This means that there is no place for a file to stick out to square up the hole. This is 136 pound per yard rail. This is the tallest, heaviest per yard piece of rail that I've worked with so far. Now I'll begin drilling out the center hole here. Right now, got the drill running at 350 RPMs. This is a 64th over 3/8. I'm going to just see how hard this material drills. Not too bad. I'm surprised at how well that went. I'm surprised. This is just a tiny bit over a 3/8 drill bit, and it seems that the flutes held up very well. Very surprising, since I had so much trouble with the 3/16 drill bits. Okay, now I'm set up with a 1/2 inch drill bit. Let's see how that one goes. Making good hot chips here, I'll tell you that. Okay, that's the 1/2 inch hole. Okay, now I'm moving up to a 21/32 drill bit. That's a little over 5/8, and I got rid of the drill chuck, and I'm going straight with a collet. These are Silver and Deming drill bits. are really heating up in there. And that's more the sound that I got out of the 3/16 drill bits when they quit cutting. And I don't know how well you can see, but boy, these are bright blue chips here. It just kind of started all at once. Switch to 41/64, which is a 64th smaller than I was using, just to see if I can get restarted in the hole. There, I must have done a lousy job of sharpening the drill bit.
This particular piece of rail was the toughest stuff I have ever encountered. It took several passes with different drill bits to finally get the center hole drilled out to size. Once I got past about 5/8 of an inch, I used several Silver and Deming drill bits from a set of Chinese bits that I have used successfully many times in the past. But in this case, once I got the hole big enough that the bits encountered the 3/16 holes, the drill bit flutes started to chip off. I assume that these bits are simple high-carbon steel, not modern alloys. Maybe I'd have avoided this problem if I had run them slower than the 350 RPMs, that is the slowest speed my mill has. This problem gave me a lot of additional drill bit sharpening experience. I did have a few older American bits that didn't have this problem. But don't be discouraged. I never had anywhere near this much trouble with any other rail pieces that I have worked with. So now on to the filing.
Once the corner holes for the Hardy hole and the big center hole have been drilled, it's time to begin filing. Here's about a 5/8 square, very coarse file that I will try to use a lot. I won't spend a lot of time with filing because it's just a lot of hard work, but that's what's got to be done next. The big thing here that I have found is that when I'm holding the file with these two fingers here, once I get going, I forget what I'm doing, and when I pull back on the file, while I've got my fingers still tightly gripping the file to maintain the pressure or pull it away or whatever, that I forget and I pull back too far and I pinch my fingers in the back end of the hole. So that's not a nice thing. So I'm just going to start here. You can see that I'm limited how far I can push the file in by the relief on the Hardy hole, or the relief behind the Hardy hole at the heel of the anvil. So if one decided to have a style where the relief came all the way back down here and gave you a clear shot out the back, I certainly could understand that. Nobody ever said this was going to be fast. The goal, of course, is to get this thing to fit in there. I hope you can see that with that short period of filing that we've flattened out this one corner quite a bit already. So it certainly is a doable thing. This is my favorite file for filing out these Hardy holes. It's about 5/8 square. It's a pretty coarse square file. I've been filing for about a half an hour now. Just take a couple of more strokes here. Again, this is my favorite file. I did use a Dremel tool with this little maybe 3/8 round abrasive tool, and I just kind of worked it back and forth to get the edges that were in the hole that you saw earlier kind of partially removed, and it worked moderately well. You don't want to go too far because then you don't have a pretty looking hardy hole when you're done, but I might use that more in the future. It does take a little bit of the grunt work out of the job. Okay, so this is my 3/4 inch test bar. Actually, my hardy tools are often a little bit bigger than this. Many of them are cast, some of them aren't. And when they're cast, there's usually a little bit of extra material on the side. But at any rate, so let's see how far I've gotten. I've got about that deep, a little over an inch. Got about 3/8 of an inch to go to get it to fit all the way through. And I'll do that off camera because you don't need to watch that happen. Here's a close-up view of what it looks like at this point. And of course the reason for going to all this trouble of the hardy hole is so that you can stick one of these guys in there and do some blacksmithing. All right. Now one thing that doesn't have to be part of a hardy hole video, but I wanted to mention is that these anvils I usually, well, so far I haven't made one with a step because I don't want to have to cut away any more of this material than I have to and make this the lead into the horn any thinner. So if you need a step, there's a simple solution. This is the equivalent of having a step on an anvil. It's just a piece of 3/4 inch shank material welded to, in this case, what is this, about a 2.5 inch cube, I think, maybe 2.5 inch cube, and just stick that in the hardy hole when you need it. This stem is a little too long, and there's no reason it needs to be that long, but if I was going to use it in this anvil, I just would cut an inch off of it. But anyway, that's a pretty handy tool for a number of things anyway, but it certainly can eliminate the need for a step.
That about says it all. A blacksmith anvil needs a hardy hole, and that's what this video was all about.